All right, class.
Yes.
All right, good job, you guys. All right, so now today we have hashtag 17. Thank you. And today's date.
124.
Yeah, 24. Yeah. Okay, so now from here. So for this one right here, we're going to go through and try to select all solutions. Now, x times x is going to give me x squared. So I'm going to write this over here. Equals 5. Yes, today is the 24th. Now, how do I undo a square? Very good. So when I do it, it's going to be x equals... No. Why is it not square root of 5? No. No. Plus or minus. There we go. Plus or minus. You guys have to remember it. It's always positive and negative. Whenever I go from the square to this to solve for it, you always have to have a plus or minus here. Okay, so now, let's look. Which one's going to be one of my answers? B, thank you. B is going to be an answer. Is F an answer?
No.
E?
C.
Okay, now, this goes all the way back to first semester when we did these problems. Now, how else could I write this? Can I write this as an exponent? So if I remember, it's 5, and as an exponent, it's always like this. It's power over root. Power over root. So in this case, this is going to be the square root, right? It's a square root, so that's going to be the number 2. But the power, we don't have anything for the power, so that would be 1. So this would be 5 to the 1/2.
Oh, so D.
D. So that's super important to try and remember, though.
That's it.
Okay? All right, so now for number 2. For number 2, I need to go ahead and put those all together. So that's going to be P to the third power, right? There's 3 of them. So P to the third is equal to 10. Very good. Okay, so to undo this one, I have to cube root. So P is equal to cube root of 10. Now, this one is not plus or minus. It's not going to matter. Yeah. Because if I square something, if you square a negative, you get a positive always. But if you take a negative to the third power, it's a negative again. That means 3 negatives together gives you a negative. So let's take a look. So my answers. Someone said E?
Yep.
Anything else? A. Is that good?
Yep.
Okay. Alrighty, so let's go ahead and I'm going to do the notes for this. So we got a lovely story for this one right here. It says, Florida man. Okay, Florida man in 1840 by himself increased the population, which was 54,500. Okay, between 1840 to 1860, he was able to make the population grow exponentially by 60% over a decade. Florida man. Do I need to say more? All right, so let's take a look. So it's going to be the same type of formula, right? So I'm going to have P times R raised to the T. So let's go through and look at my information here. What's going to be my initial amount?
54.
There we go, 54,500. Okay, my R.
20.
Okay. Now, it says right here, it is increasing. It's increasing 60%, right?
60 over 100.
Now, let's go back to our problem that we're doing yesterday. Yesterday, Angel,
What did I do?
he ended up going to the store. He had to go get his I don't know. What was that? What was that fancy?
Don't talk about it.
Yeah, his fancy chonies. Where was it? Yeah.
Target.
Huh?
Target.
Okay, so yeah, Angel, he had to go buy some new fancy chonies at Target. Okay, so when the price that he would pay if he pays full price, the price that he would pay if he pays full price, what percent would that be? 100%, right? Okay, hold on that. Now, you're getting a discount. What would I do if I get a discount? I subtract it from 100, right?
Yeah.
So that would be a discount. Okay, so that would be decreasing. But if it's increasing, I would do what? Add it to, yeah. I add it to my 100%. Because it's starting with the 100% and it's going more than that. So we're going to add that to my 100%. So it's basically 100, which is my starting amount, and it's increasing. So I add plus 60%. And Rafa had it right, and it was supposed to be 160 over 100. Okay, 160 over 100. Now, and it grew exponentially each decade. Now, what is a decade?
10 years.
10 years. So each decade. So now every time I use my time is going to represent what? 1 decade, and it's going to be 10 years. So for every 10 years, it's going to be one of these. So let's go ahead and set it all up. So 54,500 parentheses 160 over 100 raised to the so 1840 is my start, right? And in what year are we going to start with?
1840.
Okay, we're starting with 1840, but then we're doing 1850. So what is my T going to be? Yeah, it's 1. It's going to be 1 because it's 1 decade, right?
Yeah.
It's 10 years, which is 1 decade. All right, so let's go ahead and try and solve for this, please. I know everyone's calculating this right now because I know I'm staring at people and they're pulling up their calculators and they already got this, right? All right, Joshua, what'd you end up getting?
87,200.
This?
Yep. And this is going to be 87,200 people. So that's going to be in 1850. Okay, so let's do it again for 1860. So what's your T going to be for 1860? 2. Okay, I'm going to write that out again. 54500 160 over 100 raised to second, which is going to give me what? Okay, yes. So hold on. Hold on. I'm waiting for everyone to be doing this because I'm going to call on someone that doesn't look like they're doing their work. All right, and let's see. So Desiree, what do you have for this value? 39,000. 5 what?
20.
There we go. That's a lot of people, right? I know, right? Florida man over the course of 20 years. Okay, right here says population. So the population is a function of f of the number of years of decades d. So we're going to use d for this one. After 1840, write an equation for f. So f of, what's my variable I'm using?
D.
Very good. Because it said use d. Is equal to, say the whole thing. 50, 500 times
168 over.
raised to the,
Oh,
d.
Oh,
oh.
big brain.
Because it said we're using d for my variable. Good job, right? What? You good? So, question for you. George. Okay, if D represents decades, George, what does 0.5 mean? What's f of 0.5? Huh? Okay, but what does that represent though? 5 years, very good. So it's 5 years. Because 0.5 is half a decade, right? Half a decade, and half a decade is 5 years. Pretty straightforward, right? Now, graph your function. So, now I'm going to doc B. So clear this because we did a couple of extra things afterwards. So doc B it. And then, because you want to go through this. So let's go ahead and put it in my function. So we just created a thing. Now, when I put in the calculator, what am I going to use? I'm not going to use D. Yeah, I'm going to use X. So please do that.
Expand your window.
Is this what everyone got here?
Yeah, just expand screen.
What's wrong?
Our window is too small.
Yes, change your windows. Change your windows. So let's go. For those people that are following along and having trouble with your calculator, make sure you write down the steps. Menu. Window. Window settings. Now, for the window right here, what do you think the X min would be? What's the smallest X value we use? 0. Okay, remember X is representing years in this time. And X max?
10, 20.
What do you think 10 would represent in this problem?
10 years.
Not 10 years.
Days. Months.
What does D stand for?
Decades.
Decades. 10 decades is 100 years. So that's a little bit much, right?
Yeah.
So let's change this to 5. Because otherwise it's not going to fit the word problem. Y min. What's the smallest Y value I could use? 0. Because it can't have negative population. Yes, we can have negative people.
Oh, I get it.
Yes, but yeah, not negative population. Now, Y max. How much? How much?
It has to be like 70.
Think about the values that I already have. What was my starting Y value? My starting population was 54, right? After 1 year, it became
87.
87, and after 2 years, it's 139. So we probably got to go up pretty good for this one.
150.
Let's go a million. Let's go a million
I
because it's going up pretty fast. So let's do a million.
There's a 9 0.
6 zeros.
Alright, I'll look at the first time.
And once I do that, I should have this nice looking function.
Oh, that is pretty nice.
So going up a million was a little bit excessive, but guess what? Everything fits.
Wait, how do we wait, never mind.
Yeah. All right. So we graphed it and used technology to estimate the value of 0.5. Now this is slightly different than what we did before because your calculator is going to round off. And it rounds off too soon on your graph. So watch this. On your calculator, the steps I'm going to do, I'm going to tell my calculator I want to know what 0.5 is. So I go menu. We're going to trace this time. And graph trace. So once I turn on graph trace, it does this really neat thing. So once I turn that on, then I could just plug in the number that I want. Just hit the number. So I'm going to just go over here, and we're trying to look for 0.5, right? 0.5, if you notice, a little box came up where I entered my x equals right here on the bottom. Hit enter. And I have this number over here. What do you think that means?
20 0.
That's what?
6 1 6 something.
It's scientific notation.
So 600.
So we move the decimal over 4 places. You move it 4 places to the right. So it's a big number, but it's approximately. So it rounds off here. So I'm going to show you the neat trick, and this is going to work out for the rest of the semester because you're going to have to do this a lot. So this is where I'm teaching you the trick. So now, we know that this is in F1, right? Let's leave this graph and go to the regular scratch pad. So now we're on the regular scratch pad. And there's this button right here next to delete, which says vars. Hit that.
Wait, what?
The button next to delete, vars. Okay, we hit vars, and our function is in F1, isn't it? So I'm going to hit F1, and it gives me little parentheses here. So what number am I looking for? 0.5. Let's put in 0.5. So 0.5, hit enter.
Oh, that's convenient.
So the big deal about doing this is you have to put your function into the graph first, and then from here you tell it what you want. So for my answer right here, what is going to be the value of f of 0.5? 68,930, let's say 38 people. Because it's 0.7, right? And you can't have less than a person. So that's what we got right here. So 68,938 people. Now, I could also do the same thing like I did for those first 2 problems. For the first 2 problems, I hit vars, and let's try it at 1. So from 1, hit enter. There we go. And so you don't have to keep plugging in every time. Vars, and number 2.
Yo, that's big brain.
So, like I said, you're going to use this a lot this semester because you're going to evaluate for functions. All right, explain why we can find the value of p of 0.5 by multiplying this by this.
We can.
Okay, Now, we know that 160 over 100. If I turn that into a decimal, what do I get? 1.6. There's my 1.6. Now, this value right here is my exponent. So that's going to be 0.5. So 0.5. There we go. What is 0.5 as a fraction? 1/2. Very good. So I could do this to the 1/2, right?
Yep.
So I took this, which I was using for my formula, and because it's a half, I'm changing it to this. I have the decimal, and another way of writing something to the 1/2 would be the square root, right? So it would be the square root of 1.6. That's where we get this from. So it could do that. It's just another way of writing it. We did this back in the first semester, where we turned the exponents into radicals and radicals into exponents. You're waiting for that one. All right, so based on this model, what's the population of Florida in 1858?
Yes.
Now, I would like you guys, right now, I'm going to call on someone randomly. I would like for you to try and find out what it's going to be in 1858.
Oh.
So in 1858. So what do you think the first thing you have to figure out? Just the what? You said the years, right? Yeah.
So is it 8 years or
Jonathan.
So you don't want us. You don't want us to go for decades.
Oh, we are. We're still going by decades because that's what the equation, the function is.
White Rock, please report registration
Is it
officer.
18 years?
All right. Let's see. All right, Fatima.
Dewey White Rock to the registration office, please. Dewey White Rock to the registration office.
Okay. All right, Fatima. Do you know what T is yet? Or what is my D value? What's my years? Huh? It is decades. But so how many years am I going to use? Not 8. Where do we start at?
18.
It's 18 years, isn't it? But how many decades is that?
That's 1 and 1/2.
No, 1.8.
1.8? Because there's 10 years in a decade, right? So it's going to be 1.8. So 1.8 is going to be the value you're going to use. And you can use the vars again if you need to. There we go. 127,003. There you go. So in 18 years from when I started this, it went to 127,000 for my population.
You know what? These guys lose a lot of calories just to work out constantly. Most fit men on earth.
All right, let's take a look at this one over here. Okay, you guys, we're almost done with this. We're almost done here. So it says the amount of medicine in the bloodstream of a patient decreases roughly exponentially. Here's a graph representing F, an exponential function that models the medicine in the body of a patient T hours after an injection is given. Use a graph to estimate F of 1/3 and explain what it means. So let's take a look first. If we're using the graph, this is one what? Hour. So my T is hours, right? So what do you think that means? 1/3 of an hour. So what is 1/3 of an hour?
20 minutes.
Yeah, it is 20 minutes. You take an hour and divide it by 3. Okay. So, when you're done, okay? It's right here. All right, so it is going to be 20 minutes. So, let's break it up into time. Let's see, there is 12 marks in between here and here. So, if I want to break it up, if there's 12 marks in groups of 3, it's going to be 4. Because you want it divided by 3, that's what 1/3 is. So there's 12 marks here, so it's every 4. 1, 2, 3, 4. Here's my 1/3. 1, 2, 3, 4. Here's my 2/3. And 4 more gives me 3/3, which is 1. At 1/3, I'm going to go ahead and take a look, and it's right about here. So what are we going to say that's going to be?
4.7?
Okay.
I mean, that seems fair.
So we're going to say that F of 1/3 is going to be about, you said 4.7? Let's just say 5. It's really close. It's right there. So it's going to be about 5. What are my units? Yep. Milligrams. So in 20 minutes, you still have 5 milligrams left in your system. After 1 hour, there is 0.75 milligrams of medicine left in the bloodstream. Find an equation that defines F. All right. Yeah.
You really do.
Watch this. We have this, which is P parentheses R raised to the whatever T is, right? And this is going to be F of T. So we're going to use this information. So I have some points here. So I have this point, which means 1 hour, my output value is 0.75. Okay. Now, what is my starting amount? Look at the graph. It is 12. Right, Angel? So, what's going to be the T value for my starting? 0, right? T value when you start, if you notice it's right here, is going to be 0. And your initial amount is 12. Now, we're going to use this information to fill this in. So, I know my initial amount. So, my P is 12, right? Okay. So, it should be 12 times some rate. Okay, I don't know what the rate is. But I know right here, what's my T value? 1, which goes there. And that's supposed to equal this over here, right? It's going to equal 0.75 right there. we got this, right? I started with this as my initial, and it started there. And I plugged in these two right here for my t and my f of t. Because I don't know what the r is, right? I could use this information to solve for r. So let's go ahead and do that. If I want to get r by itself, what would I do? Divide everything by 12. Because I got to get rid of the 12, right? I want to keep the r to get rid of the 12. And r to the first power is just going to be r. Very good. So here it's going to say r is going to be equal to, can you tell me what that comes out to be? So people are calculating. .0625. There we go. Now, we know what r is. We know what p is. And so we could still make this a function of t, right? So t could still stay as my variable. So I'm going to write the whole thing. I'm not going to do this one right here. It's going to be f of t. That's a function in terms of time. My initial value, which is going to be 12, times my rate, which is 0.0625. And we're going to raise that to the t value. So now, by doing this, I now have a function, and I can find out anything else with this function. If I want to know any of these other values, like right here, okay, I could figure it out after 10 minutes or something else. Okay? So, pretty straightforward. We will have other problems on your homework tonight that is actually just like this, where you have to solve for this. This one's going to be due on Tuesday. This one's due on Tuesday. All right, so don't forget, like, share, and subscribe, and hit that notification.